Okay, this is a video for Math 1B and Geometry talking about perpendicular and parallel lines. It's a pretty important concept as it relates to algebra and geometry together, so it's really important since both classes are talking about linear equations. Let's dig into these concepts right here. So first of all, we need to answer these basic questions. What are perpendicular lines? That word doesn't come up in regular common conversation that often. But perpendicular lines they're basically defined by where they meet. They meet at right angles, the 90-degree kind. So if you had a line that maybe a rough sketch looks like this, then a line that has to be perpendicular to it creates exactly a 90-degree angle, and you would see usually a little notation for 90 degrees. It'd be like a little box here, or at any point where those angles would meet, okay? Now, what are parallel lines? I think most people get to that point in math before you even get to high school. Parallel lines are also defined where they meet. They never meet. Parallel lines do not, and maybe a better word than meet would be intersect. That's the accepted mathematical term. So parallel lines do not intersect. Perpendicular lines intersect at right angles. So how can we tell if two lines are parallel versus two lines are perpendicular if we don't have the graphs, right? I think we know what a graph for these looks like. If this is one, then that would be kind of a rough sketch of what one would be parallel to. So I pose these two questions. How can you tell if your two lines are parallel if you only have their equations? Same deal except for perpendicular. I'm going to answer that question by just giving you examples and see if you can see the pattern. So the linear equation y equals 3x plus 7 and y equals 3x minus 4. These two are parallel. And you would use this notation to describe parallel lines. You'd put sort of a double slash that kind of looks like parallel lines. All right, we got that. These two equations would also be parallel. Okay? They represent parallel lines. Ooh, here's one. These two would also be considered parallel. I'll give you one more. These two would also be considered parallel. Now, on the last one, just to give you a little bit of perspective, I'm going to get y by itself for both of them. I'm going to get y by itself. So, can you see it if I... Oh, there we go. So subtract 3x from both sides. Divide by -2, divide by -2. Y equals 3/2 x minus 3. Can we still see that on the board? We sure can. All right, this next one, I'll just do the work right here. Subtract 6x, subtract 6x. Y equals, well, -6 over -4. That reduces to 3/2 because a negative divided by a negative is positive, and 6 over 4 divided by 2 is 3, divided by 2 is 2. That's 3 3/4. They're parallel. Have you found the pattern yet? Yeah. Okay, it looks like the mx right here. And then on the last one, 3x over 2, 3 halves x. They eventually are identical if you put them in slope-intercept form. So here's the thing about parallel lines. If you know they have the same slope, that's the key indicator of parallel lines. Parallel lines have the same slope. And I guess there is a case where, what happens if I give you two equations that end up being the same one? They wouldn't be parallel because they would be intersecting everywhere. So take this definition with kind of like it's a pretty good definition, but parallel lines have the same slope. But I should just reiterate, say one more time, but they don't intersect. All right. Now let's talk about perpendicular. Again, I'm just going to give you a series of examples. I think that's a good way of doing it, right? Guess and check. Math's all about patterns, right? All right, so if we only have their equations, how do we determine if they're perpendicular? Well, let's say you've got y equals negative 2/3 x plus 1, and y equals 3 over 2x minus 5. Those two are perpendicular, which the symbol for perpendicularity is, it's an upside down capital T. Kind of like, hey, that's a right angle there. Let's do another one. Y equals 2x plus 5 is perpendicular to y equals negative 1/2 x minus 3. Those are perpendicular. Y equals 3/5 x minus 2 is perpendicular to y equals negative 5/3 x plus 3. You know what? I'm going to switch that. Make the negative 3/5. No, I'm not going to switch it. I'm going to leave it. Sorry. Perpendicular. Oh, this one's interesting. Y equals x plus 2 is actually perpendicular to y equals 3 minus x. That's for sure going to be a tricky one. All right, so holding out like the last example, have you guys found the pattern for what indicates the first three are perpendicular? Do you see it? There's a clear pattern of, if I flip this fraction and change the sign from negative to positive, it becomes up. That's what happened. If I take 2 and make it 2 over 1, flip it, make it negative, those two are perpendicular. If I take 3/5, flip it, make it negative, that makes them perpendicular. Now that's the interesting thing about this one. X actually has a coefficient of 1. Negative x has a coefficient of negative 1. And if we wanted to talk about that in terms of fractions, this would be 1 over 1, and this would be negative 1 over 1. So flip 1 over 1 and make it negative. Interesting, huh? So the slopes of perpendicular lines sometimes it's hard to actually describe what's happening here without using like a bunch of words that might confuse people. The slopes of perpendicular lines are We call these negative reciprocals. The word reciprocal just means inverted. For fraction layman terms, it's just flipped. All right? You flip the fraction, you make it negative. But this is the technical term for it. And I think you guys should know the technical terms. All right, now that you know the basics, let's get to some examples. Basic concepts out of the way. All right, so you're given the linear equation y equals negative 2/3 x plus 2. Would you guys be able to graph the line that's parallel to it, and it has to pass through negative 3, negative 1? Now that might seem like a totally confusing task of like, you gave me a point, how am I supposed to graph a line from a point? Well, if we know it's parallel to it, we know that there's a point negative 3, negative 1 on that line. Which means, remember, left 3, down 1. Remember, this is an x, comma, y coordinate. Don't get it confused with slope, rise over run. It's a coordinate. All right, so we know it has to pass through that point. If we knew its slope, then we could find more points on the graph. It's parallel to y equals negative 2/3 x plus 2, which means it has a slope equivalent to y equals negative 2/3 x plus 2. The slope here, if m equals negative 2/3, then m parallel, I guess I could use that notation, is also negative 2/3. Yes, okay, that means we just go down 2, right 1, 2, 3. We get another point. Down 2, right 1, 2, 3. Down 2, right 3. Or up 2, left 1, 2, 3. Take a ruler, graph it, and we're done. Well, we're done with number 1. Hey, what's the equation of the parallel line you just graphed? That's kind of going back to our first lesson there, where it was just kind of like, it's got a starting point. Remember, all these equations that are not special cases look like that. We know its slope is negative 2/3. Always put the x there. And then the plus b, down 3. Let's see here. Do I have enough time to do this one? Let's go for it. All right, so we're given the equation 3x minus 2y equals 12. On the same xy plane, create the line perpendicular to it that passes through 4, negative 1. Okay, it goes through 1, 2, 3, 4, negative 1 for sure. So we need to know the slope of this thing, but y is not by itself. Oh yeah, we know how to do that. So 3x minus 2y equals 12. All you got to do is subtract the 3x from both sides. Divide by negative 2. And then y is equal to positive 3/2 x minus 6. If m equals 3/2, that means that m perpendicular, I'll just use that notation, equals negative 2/3. Aha! So that means we can go down 2, right 3 again, or up 2, left 3. Up 2, left 1, 2, 3. All right. Okay, I messed that up. I'm bad. My bad. Sorry. You know what? Here's what I'll do. Start the video over again. Do that example. Fresh, clean slate. How's that?